look at the second case of partial fractions. Those with a repeated linear term in the denominator, something like ax plus b to the n. And essentially what this means is we're going to have several fractions on the right. An a over ax plus b over ax plus b squared, and then we keep going all the way up to ax plus b to the n. We have no idea what this is called. We'll call it b sub n. But essentially, we should just keep going up. If I have a squared term, that means I should have the regular linear term and then the square. If I'm cubing something, I should have that term squared, and that term cubed. So it corresponds to n different denominators. Here is our first example, and this time if I try to factor the denominator, I can see that I can factor out two x's to get x squared times x minus 2. The fact that that x term is repeated means on the right I have an a over x and a b over x squared. I also have a fraction for the x minus 2. This time I have 3 variables. And if I multiply both sides by the denominator, the left is 5x squared minus 3x plus 2. And on the right, I'm left with a x minus 2 plus b times x minus 2 plus cx squared. We can pick good values for x. 0 is a great one here. The right-hand side becomes 2, and on the left-hand side, we see that the a term and the c term will both go to 0. The b term goes to negative 2b. Therefore, I get b equal to negative 1. I could also let x be equal to 2. On the left, 2 squared is 4, times 5 is 20, minus 6 plus 2. On the right, both the a and the b term go away. And on the right, I have 2 squared c. Working that out, on the left, the 20 minus 6 plus 2 gives me 16, equal to 4c. So we get that c is equal to 4. We also need to find a. However, we can see that that's a little bit trickier here, because there's nothing that we can pick for x that'll make both the b term and the c term cancel and go to 0. So we have to get more creative. Essentially, we're going to start by multiplying things out on the right-hand side. This is ax squared minus 2ax plus bx minus 2b plus cx squared. We'll then regroup things based on the number of x's. So for instance, I have an ax squared and a cx squared. For x, I have negative 2a plus b. And then for my constants, I have minus 2b. And essentially now we're going to set things equal. In particular, coefficients. The left in front of the x squared term is a 5. And on the right is an a plus c. In front of the x on the left is a negative 3. And on the right, a negative 2a plus b. The constant term on the left is a 2, and on the right, a minus 2b. We can now use either the first or the second of these equations to solve for a. I'm going to use the first. We've already shown that c was equal to 4, so we get that a is equal to 1. Now that we've done the partial fraction decomposition, we can integrate. The integral of 1 over x is ln of x minus, when I have an x squared on the denominator, I have to consider the power rule. This is an x to the negative 2. So we add 1 to the exponent and then divide by that number. And then the last term is a 4 times ln of x minus 2 plus c. Our second example, if we look at the denominator, once again we can factor out an x squared, and I'm left with x plus 1 this time. And using that, we can set up our partial fraction decomposition. Because the x term is squared, we'll have an a over x and a b over x squared. And then we also have the c over x plus 1. We can multiply through by the denominator. On the left, I have 2x squared plus 3x plus 2. On the right, I end up with ax, x plus 1, plus b, x plus 1, plus c, x squared. Letting x be equal to 0, on the left I get a 2, and on the right, the a and the c term cancels. I'm left with 1 times b. So b is equal to 2. I could also let x be equal to -1. On the right, or on the left, I would have 2 minus 3 plus 2, which is 1. And on the right, the a and the b term cancels, and I'm left with 1 times c, so c is 1. However, this doesn't tell us what a is, and we're going to need to use our other method as well. Multiplying out the right-hand side gives me ax squared plus ax plus bx plus b plus cx squared. If I get the x squareds terms together, I have an a plus c. The x's is an a plus b, and then the constant is just a b. In front of an x squared on the left is a 2, and on the right, a plus c. In front of the x term on the left is a 3, and on the right, an a plus b. The constant on the left is 2, and on the right is b. We can use either the first or second equations to solve for a. This time we'll use the second. I know that b is 2, so a must be 1. When we integrate, the integral of 1 over x is ln x. The integral of x to the -2, we add 1 to the exponent and then divide by that number. Plus I still have this 2 in the numerator. Plus ln of x plus 1 plus c.